Well, friends, my background has been with the corporate sector for about 35 long years, and I have witnessed the transformation from the old system of working in India to the present system. So we will discuss what are the industry expectations are, how the expectations have undergone a change in the last few years, and what is expected in the next few years, so that we are ready for implementing those changes in the mindset of our students. We can change our curriculums accordingly, so that when our students pass out from our institutes, to a large extent they should be ready for the accepting the challenges in the industry, not only from the point of view of a competitive industry, working hard, working in a different way, but also the challenge of fast innovations which are happening, how they should be able to adopt those changes, and how they should be able to implement those changes when they are working in the industry. The industry in the last few years have undergone a major changes, and we have all witnessed to that. And that is how, when we say that our curriculum should also be in line with the industry requirements, and more so, how we make our students understand the requirements and how we change their thinking process, so that they are aware of what is going on in the industrial world and what is expected out of them. So, friends, let me take you through a small PPT also, where we will discuss the various aspects of the present industry, how the industrial revolutions have happened in the last few years, and how is the educational revolutions have happened in the last 3 or 4 years. So let me go through the presentation also, friends. I hope the PPT is visible.
Yes, sir.
Okay, thank you. Thank you. So the point is industry expectations and education 4.0. Well, friends, just to brief you that how the industry 4.0 and how is the changes which have taken place. Uh, just to give you a small brief, the first industrial revolution happened in the 18th century, when we shifted from the cottage industry to the mechanical industry, when we had steam based machines, and the industry started working in a organized way. UK was the first country across the world to implement the industrial revolution, and slowly we started innovating. And in the 19th and 20th century, we had the second industrial revolution, where we went in for mass production of goods. We started using electrical energy, and there were few of the changes which happened because of the World War One and World War Two. Specifically, in the World War Two, we found that the quality of the products that are being used, not only by the civilians but by the military people also, are not of good quality or are not defect free, because we were not into a lot of automation. Then came the third industrial revolution, that was in the middle of 20th century, where we started automating our systems. We were working on how to produce defect free products, because the first casualty when we don't produce zero defect product was the army or the defense forces in World War II. A lot of casualties happened because of the defects in the arms that were being used. When the third revolution came, we also got into the communication technology, emails came into, we started using mobile phones to some extent. The old system of telexes sending information uh, by paper was almost coming to an end in the developed countries. And again, at that time, we realized that we need to use our renewable sources for generation of power. And 3D printing also was making its presence felt. That was the third industrial revolution. But the fourth industrial revolution, what we call today as the digital revolution, completely transformed the way the business is being done. There were new ways in which technology became embedded into our systems. Today, we are talking of robotics, we are talking of artificial intelligence, we are talking of nanotechnology, and we are talking of those things which we have never dreamt of. Robos have taken place of human beings, and when we talk of automation to that extent, the quality became embedded into the products because there was new human error associated when we produce products. So from a system which was purely mechanical and everything was being done with hands, today we are talking of the technology where the robotics, artificial intelligence is taking over the human beings. So the challenge for the students who pass out now is how to integrate this technology and how to adopt the new coming up technology in the business. Earlier, we were looking at low skill levels like an operator who can operate a lathe machine or a machining center. Then slowly and slowly, we came across partial automation where the operators or the supervisors were supposed to run two or three machines at a time because some portion, some part of the process was automated. But today we are talking of a manpower who is only looking into or supervising the working of the highly automatic machines. So our engineers who pass out from our colleges will face that challenge when they come out and go into the industry. If we look at the change which has happened and which is likely to happen in the next few years, virtual organizations have been built up, and there have been so many merger and acquisitions and privatizations of the industry only because of integrating the technology with each other. We are talking of e-commerce, we are talking of digital convergence. Though our students are using digital technology, they are using their mobile sets, they are using everything digital these days, but to understand that technology is the role first of the curriculums, and then we as the faculty members who have to make them aware of the practical aspects of this new digital technology. Today, if I talk of Industry 4.0, what we also call as the fourth industrial revolution, we are talking of big datas. Anywhere we go into a shopping complex, a lot of data regarding our personal choices, how we make the payments, how much time we spend in the store, everything and everything is being recorded. We are talking of augmented reality, Internet of Things, cybersecurity, cloud computing. So you can imagine what we used to earlier look at was the efficiency and proficiency of our workers running a lathe machine. Today, the same engineer encounters the problems of system integrations, simulations. So you can see the role of the curriculum and its implementation in today's scenario. Just to give you a small view about how. So, friends, here if you see it, you have seen four Robos working simultaneously. This was basically the mainframe of a automobile for the human transport. So you have seen four robots talking to each other, working simultaneously, and ensuring that there is no collision between them. So that is the technology which our students are going to face. And if I talk of the today's shop floor, here we'll be talking of predictive maintenance instead of the breakdown maintenance. We will be talking about 95% to 98% update up keep of the time of the machinery, increased efficiency of the total process, and we are talking of almost a zero or a defect free product. And in case there is some malfunctioning in our system, the feedbacks are instant, and the source which has created the error is the identification is also instant. And here we are talking of digital technology where we get a real time data. We are talking of paperless working in the organization, and we are also talking of reducing the fixed cost. We are talking of lesser inventories. We are talking of just in time operation of the equipments, increased efficiency, transparency in supply chain, and whatnot. So, this is a typical shop floor requirements today where our students are going to work. And these requirements are also being updated very regularly. So why we need to change our curriculum and change the methodology of teaching them the curriculum? That is the major issue. Whenever we go to the industry people always feel that our engineers and the requirement of the industry, there is a large gap. They feel that the students passing out from our colleges and institutions are not ready for the industry. Basically, because the world is becoming globalized. Earlier, prior to 1990, we were confined to India. We were having Indian market as the only source for selling our products. Today, we are talking of globalized world where we are facing competition from the developed countries. Whenever we go in for selling our products, the other competitor is generally from the developed country, and we have to face that. So we need to change our teaching paradigm. The employability expectations are changing. The corporate is not looking for a person who can operate a lathe, who can supervise operation of 10 lathes. They are looking for innovations and creativity at their workplace. Employment opportunities for low skill jobs is reducing, whereas the opportunities for the people who are in line with today's technology and innovations, job opportunities for them is increasing. We have a different political scenarios across the world. Today, if we talk of Russia Ukraine war, it has again changed the paradigm of supply chain management. If we look at the pandemic which happened, the industry across the world got a hit, but those who were agile and those who could take quick decisions survived much better than the other ones. And of course, we are facing a social change within our country. Earlier, the markets were purely dependent on urban demand. Today, the same products are now being demanded by the rural population also. I talked about rapid competition. And then, as far as education is concerned, if we look at the funding being given by the government, it is also reducing. The government wants us to be self-sufficient, and government wants that the people who are being awarded the degrees should be employable outside our institution. And then we are under public scrutiny. Every time, every third day, we find that how is the rating of our institute, which solely depends upon our methodology of teaching, how our students are grasping the new technologies, what is our methodology to make them more innovative. So we are under public scrutiny also. And the communication technology is certainly spreading very fast. And what the Indian industry today is facing, the challenge which we need to inculcate into the mindset of our student is the global competition. And when we analyze that, where is the competition? Is it the quality of the product that we are selling, or it is something else. So when we analyze the data across the world with respect to the Indian products which were produced by the Indian companies, we found that one is the quality challenge. In large number of cases, we are not able to meet the quality standards which were set by US or by the Japanese organizations, because we are using still the older technology. And the second is that at many places we were beaten on the cost also. Though India is considered to be a low cost, labor intensive country, but when we talk of the cost at a higher volumes, because of the low automation, our costs are also high. So that is why we need to change our systems and the methodology with which we are working and the requirements of the industry. So when we talk of teachers today, friends, I have just discussed what is the requirement of the industry. Industry ready engineers is their requirement. But on the other hand also, if we look at the responsibilities on our teachers, our faculty members, we feel that the burden which was earlier being shared by the parents of a student has also been passed on to the teachers. Earlier, when we were the students, or probably you were the students, friends, a lot of teaching also came from our parents. But today, that role to a some extent has been passed on to the faculty members or the academicians because of the social change, because the parents, both the parents are now generally working, not able to devote time. And another reason is that they have never come across the new technology, the innovations which are happening. So they are not able to guide their children also as how to adopt the new technology. So when we talk of teachers, the responsibilities which we have today is of caregivers, counselors, nurses, coaches, administrators, trainers, facilitators, mentors, and whatnot. So that basically means that now the old teachers and the new teachers, there is a lot of difference. And that is what we need to understand as how we are going to change our systems to implement the curriculums which are getting updated frequently. Looking at today's scenario, we need to change our methodology. We need to use technology to make our students understand the new innovations. And when we talk of teacher as a leader, we need to assist them, inspire them, encourage them to understand the business scenarios. So, as I said earlier, industrial revolutions took place in the last 200, 250 years. And today we are undergoing the fourth industrial revolution. Similarly, the education also underwent a lot of changes. And today in the developed countries, we are following the education 4.0, and we will now try to understand what is the difference between education 4.0 and education 1.0. Probably when we were the students, or and some of you must also be the students of education 1.0, where the teacher used to come to the class, deliver a lecture, write something on the blackboard, we used to copy it, and that was all. There was generally no interaction between the students and the teacher. The interaction was purely one way between the teacher and the student. It was purely a teacher centered approach, and we never used any technology while teaching. And I'm sure some of you might have also seen this type of teaching systems. Then came the second educational revolution, where we started interacting with the teachers. There was a discussion between the students, a discussion between the teacher and the student, and there was more of a collaboration rather than one side authority or one side communication. But here, again, our examination system was based on memorization. Something which is written on the blackboard, we used to copy, make notes of it, try to remember what is written, and just write it down in the exam. And that was how we used to score marks. So the students were developing to a very small extent, yes. They understood what is being taught, but how to use what is being taught was not in our curriculums. At that time, some of the institutions in the developed countries started talking about learning outcomes rather than teaching. Like today, when we go through our curriculums, we do try to understand what is the learning outcomes. Will our students be able to perform, or they will only remain a student with a large memory? But still, in countries like India, we were talking about hours of teaching, not about hours of learning. So we need to convert from hours of teaching to hours of learning. That is the first step we have to take to implement the updated curriculums. Our curriculums are guidelines for us. How we are going to use the curriculum for enhancing the knowledge of the students is left to the academicians. And when this education 2.0 was happening, we also had invasion of technology. social media came into play, and a large amount of information was being available on websites. Yes, I agree that at that time, how to use the technology was not known, and there was a slight chaos whether the teacher should come and discuss in the class or teach as earlier. And curriculums were also not being upgraded on a regular basis. And we were also lacking in imparting trainings to our teachers, because as the technology changes, we are also supposed to upgrade and update our teachers how to use the technology, how to be more efficient with the new technology. All these things we need to do, but certainly we started using the new technology. Maybe we learned of our own, and a large amount of knowledge came to us during pandemic, when we were forced to shift from offline classes to online classes. Some of the institutions took this opportunity not only to learn how to use the technology, but they also modified the methodology of teaching so that the students can now understand much better and can use the information that is being given. But now, as we change the technology of teaching, as we upgraded our curriculums, earlier the curriculums were not being upgraded on a regular basis, but today we are going through the curriculums frequently, upgrading them. But along with that, the requirements of the corporate sector also got changed. Now the situation has come because of the automation. If I say today that there is one vacancy or one job opportunity for an engineer, the first thing that the management at the top will think that, will that job for which I want to employ an engineer be relevant in the future or not? Is it a long-term requirement or it is just a short-term requirement? If it is a requirement, the second point will be, can this job be automated? Instead of hiring an engineer, can I automate this job? Or can this job be entrusted to a person who is doing another job? Can he do multitasking? So before he really agrees that we should hire an engineer, he first answers the questions to these, and then only they hire. And it is felt that in the next 5 to 7 years, 25% of the roles which our engineers are doing today will become obsolete, or they will go a significant transformation. So now you can imagine that when we were talking of industry education 1.0 and 2.0, can our engineers meet these challenges or not, when our jobs are going to be obsolete, redundant, or undergo a significant transformation, will that methodology of teaching 2.0 be sufficient for them or not? Now, here, I would like to the participants to react. Is our job to teach, or we are here to do something else? Would somebody like to react to this? What is our job? Is our job only teaching, or we have some other role to play also? Any of the participant, would you like to answer this question? Okay, probably I let me go into more details. Our job is not what we do, friends. Our job is the goal that we pursue. And when we are teachers, one is that our job is to help students learn, and the second is to convert this learning to a practical, so that the society gets benefited. Here we are not teaching, or we are not passing on the information to the students. Information is available at various websites. Information is available at a click of a button. And probably to some extent, more than what our faculty members or the teachers know. So our job becomes to help the students first convert that information into knowledge, and then put that knowledge into a practical use. That is what is the aim of Education 3.0. Some of the institutions across India are shifting over to this type of methodology of teaching. But more so in the developed countries, we have already adopted this. Here, the teacher becomes the coordinator and the facilitator, not the information giver. The research is done by the student himself. And that old classical type of teaching in those countries is almost over, where a teacher used to come, deliver the lecture, or he comes and discusses that particular topic that day. Now we are shifting over to what we call as the learning plans. Now, when we say that our students need to learn these things, and if you look at the picture on the right hand side, you will find a very complex network. We are talking of information from websites. We are talking of information from peers, teachers, and we are also talking of converting our knowledge into a practical use. Now, when this education 3.0 has undergone this education system has undergone a change, and as I said earlier, the low skilled jobs are getting reduced and we are talking of high skilled jobs. The job has also undergone three revolutions. Now here we will be talking more about the engineers who are passing out today with the skills which are required by the industry. If you look at the job revolutions and comparing it with the education systems, the first job revolution we called as the industrial revolution, when industries got promoted in our country, and this revolution lasted till 1992 before our borders were opened for the MNCs to come in. Before that, even when I was working with the automobile industry, we said that our job is for our survival, what we call as the roti, kapra, and makan. Because the job opportunities were very less, and we were taught that boss is always right. Whatever working conditions we got, we used to work. There were no air conditioners in the offices. When the people were working on the shop floors, they were sweating. There was no place for them to sit down. But that was because the opportunities were less and there was no reason to shift to another job where the working conditions or the job or the salary would almost be the same. But in 1992, MNCs came into India. They brought with them a lot of technology, but they also brought with them higher pay packets. And they changed the working conditions not only in the offices, in the shop floors also. The living standard of the students or the living standard of the employees underwent a change because of the more money in their pockets. And when they came into India, the job opportunities also became available. People started looking for better work conditions. And this continued till 2010. In 2010, the innovations and the creativity took over the industry. And so did the jobs. Informations which were available on YouTube and digital media became available to each and everyone. There was no knowledge which was hidden. And those students who adopted this new technologies, started studying those new technologies, started getting jobs in the high-tech industries. Now, when this revolution happened, the requirement of the employees or the officers or the engineers also underwent a change. They were living in good standards, but they were looking for good quality of life now. They did not accept the old working conditions. More so, those engineers started looking at the industry from the growth point of view, not only from growth for the industry, but their personal growth. Will this industry teach me something new? Will my personality undergo a change? Will I get reward for the work that I'm doing? So now you can imagine how the revolutions in the job scenario happened. Today, when our students pass out from these institutions, not only about the salary package that they get, they also look for good quality of life. Now, that quality will be available to them provided they meet the industry requirements. So many of the technical institutions have come up in the last few years. I'm not saying that the number of jobs are not available. I would say, from the industry point of view, that number of students who can undertake the jobs as per our requirements are not available. For our students, the recruitment methods have also undergone a change. When I was employed by my industry back in 1980s, the standard procedure was to hire us, train us, depute us for the on-the-job training, and then they expected us to give an output. And the total time span was 8 to 10 months. So that means for 10 months, the organization used to pay us salary and not expected much output from us. Now, there are two recruitment methods which are being used by the industry. First is that they say that we will hire them if they are trained. So the training time they want to cut down to minimum. So the training best can be given by our institutions. If they are trained to deal with the latest business scenario, the industry will hire them and deploy them, give them on the job training, varying from industry to industry. This time is from 15 days to 6 months. But today, if you look at the job scenarios, we are talking of contract employment also, where the industry feels that they are well trained. The hiring is done by somebody else, training is given by somebody else, but when they join the organization, they are given only and only on the job training, and the output is expected between 15 days to 1 month. Now you can imagine that how our methodology has to undergo a change to make our students compete with these recruitment models. The industry today looks for those engineers who have enough practical knowledge. And if I talk of today's requirement by the industry, when we set industry expectations, our engineers shall be trained to handle complex problems. Critical thinking, creativity is a part of their jobs and skill level. People management, quick decision making, customer service orientation, flexibility, negotiation skills. Probably, if we look at these skills, you might wonder that in 3 to 4 years, what we have taught to them technically doesn't figure in the new age requirements. And to a large extent, I agree with you that industry 30 years back was looking at whether I know how to operate machines, whether I know what is hydraulics, whether I know what is thermodynamics or not. For an electrical engineer, whether I know what are the transmission lines, what are the design features of a transformer, how to run two transformers in parallel. Similarly, in civil, everything was purely technical, and our job interviews were also on the basis of our technical knowledge. But friends, today that technical knowledge makes only maybe less than 50% of the job requirements. We are more looking at problem solving techniques. We are more looking at critical thinking. We are looking at innovations. So that means that our methodology has to change to make them innovative, thinking out of the box. Today we talk of artificial intelligence, digital skills. So, friends, if we look at the skill mismatch of our students because of the growing role of automation, our students have to be prepared for reskilling themselves. We do come across our curriculums which are multidisciplinary. When I was appointed as an electrical engineer in an automobile company, my job was to look after the electrical portion of the automobile, how the wiring is being done, whether the lights are working or not. If there is a problem, can I detect where is the problem in the wiring? We used to have a mechanical engineer who used to ensure that the assembly of the sub-assemblies or the components is as per requirement. And slowly we had also added an electronics engineer who would look after the electronic part of the automobile. But today, if I have to hire an engineer for my automobile industry, I'll be looking for a person who can do all the three things together. So, our methodology of teaching has to shift from our core competencies to multidisciplinary also. Whether I'm an electrical engineer or a mechanical engineer or a computer science engineer, I must know what is artificial intelligence, what are robotics, what is data analytics, what is blockchain. So that is, I may not be proficient in everything, but I must know what are these things and how they can be used. Today we are talking of programming, supervising, troubleshooting within one machine, troubleshooting between interconnected machines, as I was talking about the Robos. And we have to look forward as to what technology will come now, and can I start working on the technology right now. We don't know exactly what will come, but certainly we should be flexible enough to adopt the technology whether it belongs to my stream or not. Well, friends, now I have again given you a brief about what is required. Here comes the role of the Education 4.0. Here, those institutes across the world who have adopted this methodology, they feel that the information and the knowledge is available on the websites at the press of a button. So the faculty member or the teachers need not talk about those technologies, the theory of the technologies. They are talking of how to use those technologies for innovation and creativity. That's why we say now those institutions are shifting from learning plans to creativity plans. How many projects were given to the students? Did they learn something new in the projects? How much time did they spend in the labs? Are they ready to work with their own hands? And that is what they are looking for. In Education 4.0, we are talking more about the practical aspects of our knowledge. Yes, I agree that we are bound by the AICT or UGC regulations where we say 70% of the time probably for the theory classes and 30% for the practical. But they are leaving it to us what we teach and how we teach in the theory classes. Can we talk about the practical aspects instead of telling them the three laws of Newton? Can we discuss how to implement those laws? The curriculum will say that we need to teach them the Newton's three laws, but it is on us to decide whether we dictate these three laws to them or discuss the practical aspects of these laws. So the point is that can we change our methodology to such a way that we move from theoretical knowledge to practical knowledge? When we talk of Education 4.0, friends, learning can take place anytime, anywhere. The role of classroom is to convert the theoretical knowledge which they got outside the classroom into a practical shape when we meet in the institution face to face. In those countries, the learning is becoming customized depending upon the strength and the weaknesses of the students. In a classroom, we can also experience this that there are few students who are above average and there are few students below average. Till today, our methodology of teaching is almost the same for all the students. But when we talk of Education 4.0, we are talking of customized way of learning based on strength and weaknesses. Some students must be good in data analytics, some students must be good in research, some students must be good in innovations. So we need to change our methodology in that way. And if you look at the national education policy, which was released about 2 years back, the way we are going to assess our students is also going to change. They will be tested by way of performance in the field projects and assignments rather than remembering the formulas. So that is what is education 4.0, and how we can help the student. They have to be more creative, innovative, and we need to be collaborative. We need to combine our knowledge, our skills, and techniques in such a way. And well, again, let's not be bound by the curriculum which is written. Can we assign the activities in such a way that those activities become aligned with our curriculums? Let them learn the curriculum's practical way rather than the theoretical way. Let them build solutions. I know it is a revolutionary steps that we are talking of. But friends, unless or until we give them practical experience, whether through projects, whether through assignments, whether through 2 months of industrial exposure, whether it is industrial exposure for a shorter time, unless or until they are aware of the environment they are going to face once they come out of the four walls of our institution, they cannot be successful. Today, our students are facing the global competition. But here, when I talk of the need for the day, the talk of the innovations, the first point that comes to my mind is, if I am talking from the industry point of view, are our faculty members also aware of the new innovations and technologies? Have they ever witnessed the working of these technologies? Unless or until we have come across ourselves how the new technology innovations are being used, probably we will not be able to make our students aware of them. We need to first understand that upgradation among us is also required. And once we learn that what are the new technologies that have come up, how they are being used efficiently, what are the advantages of those technologies, our teaching methodology will automatically undergo a change. We will start discussing the technology, giving the practical examples which we have seen with our own eyes. When we talk of innovations, if we are exposed to those innovations earlier, if we are aware that the technology can be used for converting our creative plans to innovative plans, we can be much more successful. Once we are aware of it, we can give more emphasis on entrepreneurship development. We have carried out 2 or 3 experiments without the formal approach which we undergo when the teachers undergo a training, we have requested some of our teachers to visit the industry during the off days, during the summer holidays, winter holidays, after having a tie up with the industry. They spent about 2 weeks' time in that environment where new technologies are being used. And when they came back to the institute, the level of understanding the new environment was absolutely different. They could relate the curriculum with the practical use in the industry. If we feel that that is one area where students as well as the faculty needs to learn the new systems, we had tried another way. We entered into a memorandum of understanding with the industries around the institute for training not only our students but our teachers also. For 2 weeks to 1 month training was imparted to the teachers as well by them, and that completely revolutionized the methodology of teaching in those institutes. Yes, entering into an understanding with the industry is certainly difficult because they feel that their efficiencies might reduce when they have to deal with the teachers, when they have to give them the knowledge. But at this moment, if we look at the desperation level of industry, because they are not able to fulfill their job requirements due to non availability of students, they are ready to invest in training of both teachers as well as students. Let's involve them in our incubation centers. Let's get mentoring for them. Not only for the students, we will also learn. Let them institute some awards for innovation in our institute. So that is the way our students will also learn to be more innovative. There are few industries who are ready to give seed money for the innovations and startups for our students. But we need to collaborate with them. We need to tell them that this is what we can do and this is what we expect the industry to help us. And if I talk of innovations, the industry is always ready to encourage startups. Whether the startup belongs to their field of product or not is not the question here. The question here is that can they help our students, motivate our students, encourage our students? And the best way to do is entering into a memorandum of understanding. If we go to the west of our country, there are few institutions who have entered into the MOU with the medium scale and the large scale industries. The students passing out from those colleges and institutions are much better practically oriented than other students. So we need to change our methodology of teaching. We need to change our thinking whether the industry can join us and share their views with us if we really want to implement the curriculums which have been designed. If we look at the curriculums and the upgradation of curriculums in the last 2 to 3 years, to a very large extent, they match the requirements of the industry. I had the privilege of going through some of the updated curriculums by Dr. Gupta. And I also discussed those curriculums with the industry leaders also. And they were quite happy that, yes, the educational institutions have at least started making curriculums as per the requirement of the day. Now it is for us how to implement and use that curriculum. And the more emphasis we give on practical trainings, projects, the more successful those curriculum will be. I again say we are bound by the UGC AICT regulations, but we can certainly discuss the projects in the classrooms, look into the problems the students are facing when they make their projects. Today we are talking of 70% theory and 30% of practicals and 2 months of probably a training. I would say that as far as theory is concerned, let it be 30% only instead of 70%. And let 70% be divided into two parts, probably 40% for the lab work and another 30% for the projects. Let's give them more projects. Let's give them the lab projects which are new. Let's not repeat those experiments which were done by the previous year, 2 years back, 5 years back. Can we innovative? Can we design some new experiments for the labs so that the students learn something new? Similarly, let them go through multidisciplinary projects where they learn about the other streams. Maybe a software writing, an easy one. Maybe how to design, how to use a mechanical product by an electrical engineer, or by a mechanical engineer, can he learn something about electronics? Yes, we ourselves will face issues, but let them go into a collaborative projects where institute can be a great help. And if such projects are out of the problems being faced by the industry, the industrial house will also be very happy to associate with such projects. So friends, before I conclude, I have only one request or the advice. Advice comes from the industry experts and request comes from the one of your academic institutions. Let us change the methodology of teaching. Information and knowledge is available with the students. Give it a practical shape. Thank you, friends. This is what I wanted to add. And we also look for sustainability and meeting the students' aspirations. That is what we are there as faculty members. Thank you.